Orange 6, welcome to Wednesday, another lesson in math class. Hopefully you've taken Power Up A probably for the last time this year, and then you're going to have it on your test on Friday. This will be the front side of one of your tests to challenge yourself. I'll work through the problem solving with you. It says this. In one section of a theater, there are 12 rows of seats. In the first row there was 6, in the second row there was 9, in the third row there was 12. If the pattern continues, how many seats are in the 12th row? So I have the pattern here, 6, 9, 12, and what we could do is, step 1, keep that pattern going until we get to the 12th row. So 15, 18, 21. If you're looking at it, you're saying, I know what the pattern is. The pattern is up 3. So instead of adding 3, we could multiply by 3. And I could say 12 times 3 is 36. There's 36 in that 12th row. But that's not quite right, guys. Because if I said, how many seats are in the first row? The first row was 6. It wasn't 3. And so I would take first row, 1 times 3, and then I have to add 3 more. 2 times 3, and add 3 more. So they're teaching you to try to write a formula, guys, and the formula would look like this. K equals, what am I going up by? 3's, by the number of rows, and I have to add 3 to it. So it's kind of like some problems you've been getting where it's like K equals 2n minus 1. This is what my formula is. The number of rows times 3, because I'm going up by 3's, and then I have to add 3 to get that. And so 3 times 12 is 36, plus 3 is 39. So your real answer is 39. It was kind of tricky. Some of you did 12 times 3 and got 36. That was good. Step 1, we needed step 2. Your other choice was obviously to say row 1 had 12, row 2 had 9, row 3 had 16, row 4 had 15, row 5 had 18, and I could literally go until I get all the way up to 12. If this was a question on my test and I didn't know how to do this yet, I would have taken the time to write row 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, and then fill in the answers to get to 39 seats. Okay, we'll go back from a review from yesterday. Yesterday we learned adding, subtracting, and multiplying fractions. When we add and subtract, they came with common denominators, so we add or subtract the numerators, the denominators stay the same. When we multiply the numerators, then we multiply the denominators, so the denominator is going to change. And so I like to say multiply the tops, then multiply the bottoms. Then we also learned what we call reciprocal, to invert those fractions or to flip them over. So the numerator becomes the denominator becomes the numerator. That's the reciprocal. That led us to the inverse property of multiplication. Any number times its reciprocal equals 1. We're going to use that one a lot. Today we're moving on. We're getting ready to get a step closer to doing division problems and build off what we learned yesterday. Today's lesson is kind of the opposite of each other, what we call the inverse of each other. So you have writing division answers as mixed numbers and then turning those mixed numbers into improper fractions. Hopefully your yellow folder's ready. We got a few points to work through and a couple blanks to fill in. The new concept on page 66. Alex cut 25-inch ribbon into 4 equal lengths. How long was each piece? To find the answer to this question, we divide. However, expressing the answer as a remainder does not answer the question. So I divide in there, goes in there 6, I have a remainder of 1. It says, interpret, what unit of measure does the answer remainder 1 stand for? Well, it stands for inches. How much do I have? I have 6 pieces with a remainder 1 inch. That doesn't make sense when we're talking about lengths. Okay, the answer 6 remainder 1 means that each of the 4 pieces is 6 inches long and that a piece remained that has 1 inch long. But that would make 5 pieces of ribbon. Instead of writing the answer with a remainder, we will write the answer as a mixed number. The remainder becomes the numerator of a fraction, and the divisor becomes the denominator. So I do the same thing. You notice you have at the top of the page the remainder of 1. That's your numerator. 4 was your divisor. That becomes your denominator. So my answer is 6 1/4. This answer means that each piece of ribbon is 6 1/4 inches long, which is the correct way to answer this math problem. Coming up, guys, we're just going to learn remainders are going to start to go away for us this year. We're going to get them a few more times, but eventually all our answers are going to be mixed numbers or decimals. You're at a high enough level of math that we don't talk remainders anymore. Number 1, it says, what percent of the circle is shaded? So I have a little drawing up here, it's 1/3. So what they're saying is, can you take 1/3 and switch it to a percent? Now some of you, I pray, have this one memorized already and your answer's done. But those of us who are doing math, we learn percent means out of 100. Remember, the word cent, there's 100 cents in a dollar, guys. That's why it is that. So I'm going to divide it by my denominator, which is 3. 3 goes into 10 3 times, that gives me a 9, I subtract 1, bring it down, 3 goes into this 10 3 times, that's a 9, I subtract, I get 1. Now today's lesson says it's not 33 and remainder 1, this becomes your numerator, and 3 is your denominator. And so I have 33 and 1/3%. Okay, improper fractions. It says a fraction is equal to 1 if the numerator and denominator are equal and are not 0. Here we show fractions that are equal to 1. 2/2, 3/3, 4/4, 5/5, go on forever. They're always equal to 1. A fraction that is equal to 1 or is greater than 1 is called improper fractions. So as I'm going through my notes, guys, we already worked through the first one, right division as mixed numbers, meaning putting the remainder as the numerator and the divisor as the denominator. Now we got our first fill in the blank. Improper fractions, numerator is equal to or greater than the denominator. Speaking not correctly math, we say bigger numbers on top. Okay, normally with a fraction, the smaller number is on top. And so now you know what an improper fraction is. Continuing back in here, improper fractions can be rewritten either as a whole number or as a mixed number. Let's do example 2. It says draw and shade circles to illustrate 5/3 equals 1 2/3. So I have my 2 circles here, and I'm going to start with 5/3. Okay, I took this one and I chopped it into thirds. 1/3, 2/3, 3/3. Now I take this one and I chop it into thirds, 4/3, 5/3. If we look at and we're counting by thirds, I have 5/3. What do I really have here? I have 1 whole, and this one is 2/3. So it's 1 2/3, which is the same thing as 5/3. They're just going back and forth with a picture now, so that we can go back and forth in math. Turning the page, you got example 3. Convert each improper fraction to either a whole number or a mixed number. Guys, this line means divide. So I have the saying Tibo or Tybo, top in, bottom out. So if I spell Tybo like this, T-I-B-O, this stands for top number in, bottom number out. Top number in the box, bottom number outside the box. Then it's a division problem. How many times does 3 go into 5? Once. 3, subtract 2. Today's lesson says numerator, denominator, 1 2/3. Improper fraction, how do I switch it to a mixed number? Top number in, bottom number out. 3 goes into 6 2 times. Problem solved. Example 4 says rewrite this as a proper fraction. They gave me 3 7/5. Top number in, bottom number out. 5 goes into 7 once, it's 5, subtract 2, I have 1 2/5. I take that 1 and I add it to the 3. And 1 plus 3 is 4. My fraction stays the same. I have 4 2/5. So that's like when we do an addition problem, we get these answers, you'll see that in a second. We don't leave it improper like that. Example 5. Let's do this in what we're really going to do, math class now. So I start out with 4 plus 4 is 8. The 5 stays the same. Now, last lesson that could have said, good, we're done. Today's lesson says, no, no, no. You know how to make this into a mixed number, so make this into a mixed number. How do I do that? Top number in, bottom number out. 5 goes into 8 once, that's 5. Subtract 3, I have 1 3/5. B, let's multiply. 5 times 3 is 15. Multiply the bottom. 2 times 4 is 8. Switch to a mixed number by division. Top number in, bottom number out. 8 goes into 15 once. That's an 8. Subtract 7. 1 7/8. Some of you, as you start getting this practice down, will be able to do that. Look at 15/8, say it's 1 7/8. Your brain's going to start doing that automatically. Letter C. I wrote them up and down. That makes addition easier for me. 3 plus 3 is 6. 5 stays the same. I like to, right now, switch this one to a mixed number before I do the addition. So I say top number, sorry, that's an ugly 6. I say top number in, bottom number out. 5 goes into 6 once, that's a 5. I have my 1, that's 1/5. I take this one, I put it right here, and say 1 plus 1 plus 1 is 3. Do not forget that fraction over there. It's 3 1/5 to get your answer. Okay, now we got the last thing to do. We just took improper fractions and we made them mixed numbers. Now the rest of the lesson is saying, can you do it the other way around? In between example 5 and 6, it says, sometimes we need to convert a mixed number to an improper fraction. The illustration below shows that 3 1/4 can convert to 13 1/4. We see that for every whole circle that equals 4/4. So if there's 3 whole circles, I have 4/4 plus 4/4 plus 4/4 plus the 1/4 gives me the 13/4. That's one way to do it. Take your wholes, make them what your fraction are working with. So I'm working in 4, so I make them all 4/4 plus 4/4. We're going to skip example 6 for 1 second. I'll go underneath it because they're going to teach you how to do that without drawing pictures and doing big addition. It says the solution to example 6c suggests a quick way to convert a mixed number to an improper. How do I convert 12 1/2? I take the denominator, I multiply it by the numerator, denominator times the whole number. I take 2 times 12, that gives me 24, and I add my numerator, that adds up to 25. And then the denominator stays the same. If I'm in my yellow folder, what does it say? It says mixed number to improper. Multiply denominator by whole number and add the numerator. Guys, this is what I like to do all the time. I like to do exactly what they did at the thing, draw that little circle. So now going back to example 6, it says, can you write these mixed numbers as improper? The first one they gave me is 3 1/3. So it's multiply and then add. 3 times 3 is 9, plus 1 is 10. Stays the same with my denominator. 2 times 4 is 8, plus 3 is 11, and I have 11/4. 2 times 12 is 24, plus 1 is 25/2. Multiply and add, multiply and add, multiply and add. We need to know how to make improper fractions for when we multiply and divide mixed numbers. So that's coming up lessons later. They're starting to build the base for us to be able to work through those problems. You got the practice set, 6th grade. Remember, do whatever practice ones you need that are necessary so that you have this concept down and you got it in your head. Tomorrow we're going to do investigation number 1, and then on Friday we're going to take our first math test. So obviously that test is going to be a big deal. You'll show that you understand everything without me giving you the answers and walking your way through that. Keep doing this practice stuff on the back of your quiz so that you can show work. Always be showing your work and doing the work with me. We'll see you for math problems. All right, 6, here we go with problem set 10. The first problem we're doing is number 2. It says use the words perpendicular and parallel to complete the following sentence. In a rectangle, opposite sides are, so this side compared to this side, they're both going vertical, so opposite sides would be parallel. And adjacent sides, adjacent means they touch. So this is adjacent to this. This is adjacent to this. This is adjacent to this. So adjacent means they touch somewhere. So these sides, guys, in a rectangle are perpendicular. All right. Number 4. What percent of the rectangle is shaded? So the first thing I do, I have to count how many boxes there are. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. There are 10 boxes. How many are shaded? 3. If we were doing this, percent means out of 100. So I divide by my denominator and I multiply by my numerator. So 10 goes into 10 once, 10 goes into 0 times. 3 times 10 then is 30%. So divide by my denominator, multiply my answer by my numerator. What percent of the rectangle is not shaded? The whole thing is 100. 30 is shaded. I subtracted and got 70% is not shaded. Number 5, write 3 2/3 as an improper fraction. So I have 3 2/3 from today. Remember, we multiply and then we add, and it just goes in a circle. So 3 times 3 is 9, plus 2 is 11 over 3. Number 7, point M represents what mixed number on the number line? So I have my big number line here, guys, and I'm between 9 and I'm between 10. The first thing between 10. The first thing I do is count the number of tick marks there are, or I shouldn't say tick marks. I had to count ticks to draw it for you. I'm counting spaces. 1, 2, 3, 4, 5, 6. So I know my denominator is 6. Now M is right here. I go back and I count my tick marks. 1, 2, 3, 4, 5. So that makes that my numerator. And then don't forget your whole number. It's 9 and 5, 6. Number 9, list the single digits numbers that are divisors of 420. I write 420. I add my digits together. 4 plus 2 is 6. 1, because it goes into everything. 2, because it's even. 3, because it goes into 6. 4, because it goes into 20. 5, because it ends in 0. 6, because of 2 and 3. 7, because I can do 420 divided by 7. 8, I have to see. Remember, 8 is the last 3. Well, there's only 3 numbers, so I have to do the whole division. Goes in there, 40, 20. 8 doesn't go into 20, so 8's out. 9 is out because 9 does not go into the 6. So I have the first 7 numbers, guys. 1, 2, 3, 4, 5, 6, 7. Number 11, 18y equals 396. This means multiply, letter next to a number. Missing in multiplication, I divide. 396 divided by 18. Goes in there twice. That's 36. Subtract 3, bring down 6. I already know that one. Goes in there twice. Is 36 again. So I have an answer of 22. Number 14, missing the first in subtraction, I add. Remember, if you're struggling on do I add or subtract, you can write that thing backwards. Writing it backwards would look like this. 8.75 plus 12 plus 1625 equals B. Well, that's an easy addition problem, guys. So write subtraction backwards if you're struggling, if you have to add or subtract. Okay, that's a really sloppy 875 there, sorry. So ignore that. 5 plus 5 is 10. 127 is 10. 168 is 15. Carry the 120. 5, bring down, $sign. I have $25. Flipping it over on your answer key, we're up to number 16. Arrange these fractions in order from least to greatest. Okay, you got 2 choices. You're good at fractions. You're good at deciding which one is more or less than half, or you're back to page 56. Page 56 has my inch ruler. On my inch ruler, I see that 1/16 is the first one, 3/8 is the next one, but it's still less than half. That makes a half next, and then bigger than half is 3/4. Do whatever gets you comfortable, but you want to continue to work these things to get them into your head to be able to make math easier and faster for you. Number 19, I got common denominator, so all I'm doing is adding. I'm going to do 11/20 plus 18/20. I add the top. 1 plus 8 is 9. 1 plus 1 is 2. I have 29/20. Now today I have to switch that into into a mixed number because it's improper. Top number in the box, bottom number outside the box. Goes in there one time, gives me a 9. Denominator stays as my divisor. I have 1 9/20. Number 20, parentheses says do it first. So I have 680 minus 59, borrow, 10 minus 9 is 1, 7 minus 5 is 2, 6 minus nothing is 6. Now I turn around, I take that answer, and I'm going to subtract again, this time from 2,000. So 2 becomes 1, 10 becomes 9, 10 becomes 9, 10. 10 minus 1 is 9, 9 minus 2 is 7, 9 minus 6 is 3, 1 minus 0 is 1, and I get an answer of 1,379. Number 22, we're adding money. The first one is 89 cents. I make it look like $1. The next one is 57 cents. I switched it to dollar format, and I did that because of the last one is $15.74. So they all need to look the same. Then it's straight addition. 9 plus 7 is 16, plus 4 is 20. Carry the 2. 2 and 8 is 10, plus 5 is 15, plus 7 is 22. Carry the 2. 2 plus 5 is 7. 1 plus nothing is 1. Dollar sign down, decimal down, $17.20. Number 24, I have 2 2/3 plus 2 2/3. I'm adding those together. 2 plus 2 is 4, and it stays the same, so I have 4/3. I'm going to switch that to a mixed number by dividing, top one in, bottom one out, goes in there 1 and 1/3 times. I'm taking my whole number answer and I'm adding it to my other whole numbers. 1, 2 is 3 plus 2 is 5, and then I don't forget my fraction, 5 and 1/3. 27 says how many 5/9 are in 1? This is the reciprocal. 5/9 times, flip it, 9/5 equals 1. Okay, number 28 says what are the next three numbers in the sequence? 32, 16, 8, 4, 2. I'm cutting it in half. So I divide 2 by 2 and I get 1. I divide 1 by 2, I get 1/2. I divide 1/2 by 2, I get 1/4. So we switched it around, guys, and we're going up with these things now as a denominator. Okay? So 1, 1/2, 1/4. Next one would be 1/8, 1/16 if they wanted more of those. Number 30 says if A minus B equals 5, what does B minus A equals? This might bother you because we don't know what B and A are. We just know that it equals 5. Now, if you're good in subtraction, you remember that this is the opposite. But what I'm going to do is I'm going to say, I don't know what A and B are. I'm going to make it up, guys. A is 10. B is 5. And how do I know that? Because I know 10 minus 5 is 5. So I just made up my answers. Now I do it the other way. 5 minus 10. Well, guys, anytime you have this, remember we switch it around to 10 minus 5 is 5, but because I switched it, the answer is negative. So what they're trying to tell you is, hey, do you remember that when you have it the one way, it's positive, and when you have it the opposite way, it's negative? This is what they're hoping you remember, the relationship. But if you can't do that, guys, make up your own numbers. You could have used 8 and 3 or 6 and 1. It doesn't matter. You could have used 5 and 0. But you're allowed to pick any numbers you want and do the math problem. B, W divided by X is 3, so what does X divided by W equal? Well, I don't know. So I'm going to do 3 divided by 1 because that equals 3. Now flip it over. It's 1/3. They're hoping you remember that from your lesson yesterday, that when we switch the order of division, it becomes the reciprocal. So maybe it didn't take you any work to get 1/3. If you can't get that automatically, go back and pick your numbers. C, how are W divided by X and X divided by W related? Well, what's the word for that when we flip those things over? The math word is they are reciprocals. So make sure you're knowing your math terms. They are related as reciprocals. They will equal 1 when we're done as the inverse property. Awesome.